So for this problem, we want to use the technique in order to estimate the instantaneous rate of change for the function g of t equals to 3t squared plus 5 at the point t equals to 1. So what we're trying to do is we're trying to find the different slopes as our values of t get closer and closer to 1. So we have to start a little bit further away from t and get closer and closer, or t equals to 1, and get closer and closer to it. So just like we did in the previous problem, we know that our values are trying to get closer and closer to 1. So 1 is going to be our starting point. And we can pick something like 1.5. And then we can pick something like 1.1. And then we can pick something like 1.01. And then we can pick something like, oops, sorry about that. We can pick something like 1.001. Now remember that this is a closed interval, so these are x values. This is like your x1 and x2. And we also know that slope is given by f of x2 minus f of x1, which is y2 minus y1, divided by x2 minus x1. So for all of these problems, we have our x1 and we have our x2. So here we have f of 1.5 minus f of 1 divided by 1.5 minus 1. Here we have f of 1.1 minus f of 1 divided by 1.1 minus 1. Here we have f of 1.01 minus f of 1 divided by 1.01 minus 1. And then finally, we have f of 1.001 minus f of 1 divided by 1.001 minus 1. Now, of course, we don't want to do this by hand. It'll take way too long. So you can use a graphing calculator to do this. I'm going to use Desmos.com since I won't be able to display a graphing calculator. So in Desmos, what I'm going to do is I'm going to say that g of t equals to my function, which is 3t squared plus 5. And then I'm not going to do all of these, but I'll do one of them. Or a couple of them. So I have g of 1.5 minus g of 1, and then that whole thing is going to be divided by 1.5 minus 1. And notice I get 7.5. Then I can do the exact same thing for my next interval, which is 1.1. And then I can do the same thing, actually I'll just do all of them, for my next interval, which is 1.01 to 1. And then my last interval was from 1 to 1.001. And so what we can see is that at the point x equals to, or in this case t equals to 1, which is going to be right about there, right over here, we want to estimate the slope of the tangent line at that point, at the point 1, 8. And if you were to draw a tangent line at that point, then that tangent line is going to have a slope of approximately 6, because notice that these slopes are getting closer and closer and closer to 6. So here we have 7.5, here we have 6.3, and then we have 6.03, and we have 6.003, so they're getting closer and closer to 6. So our answer here is going to be 6.